Okay, let's start. Most of them have joined. Others will be joining soon, so we can be on our way. Last time in part one, we have seen how technology database can be modified and handle different parts and different features that is available. Plus defining the machines, defining import export option at technology. You can export your tools, modify the Excel sheet and import it back. So you get tools very easily in your database. So many of you try to make user-defined tools many times, but it is not required. So you should actually look for all the standard tools that are available, try to modify those and make them like your tools. So most of the times I have seen as user-defined tools are not required. You should be using all the tools that are available in the tool list. Okay, so you go through them. So you have a tapered tool as well for the flat end mill taper, the ball end mill tapered, the bull end mill tapered. So all these different tools will be available. The negative taper. So you should be using all these tools. Defining material, so we have gone through that. So defining speeds and speeds, defining automatic, how the tools and strategies will be selected automatic for such parts. So we have seen that. So today we'll be going through the mold base. Okay, so the mold base will have many different types of holes in a plate. So you need to automate those features as well, so that from mostly what we have seen in mold base, many of these plates would have a similar set of holes. Okay, depending on the size of the mold, they will have similar set of holes in different plates. The returner plates for these pins will have many holes. Okay, so these are some of those holes that you see in the picture right there. Some of the holes that can vary from different sizes and different this thing. So you have holes which can hold your ejector pins, which should not rotate. Okay, so you have those yellow holes with flat ends. So different types of holes. Those are very similar to what we have seen in the mold base. So we'll try to set those strategies for those holes. Then we'll go into the TechDB for TBM strategies for setting up the parameters for TBM. Then we can have a look at the core and cavities. Okay, let's get started. So we go into CAMWORKS now and open one of these parts. All right, we'll close the database now. We'll open one of these parts. Now, to these parts, let me first create the features. So all the features are extracted very quickly, and then we'll set the parameters for any one of those holes, and to show you how they can be set. So firstly, let me delete some of these not required. Just get into some. Let it be. I will not waste time. So let me get to one of these holes. Okay. Now if I just right click and say generate the operation plan, you'll see a set of toolbars in there. Okay. Now the central drill, then the drill, then the countersink to maintain the flat, and then we'll have a countersink for the chamfer. Okay. Now, if I double click any of this toolpath, it will guide me to which database option here under feature options. So I can directly from here go to that technology database option. This is an easier way to go into the database and check. So it will take me to that particular location, and you can find all these toolbars here. Okay. So description of that was example 1, and you will have all these strategies. So it is getting all these strategies from here. Okay. So it is getting to the central drill, using an expression for the diameter, so it is directly going for that fixed tool, selected tool from the library. For the drill, it is taking that expression, so cylinder for the diameter and expression for the tool summary. So it is getting directly reading the cylinder and getting you the tool automatically from the database. Okay. So this again, there is an expression for the tool. If the diameter goes small and big, you can also go for the expression or directly go for the tool here. Okay. So depend on what you want. If you want the expression, you can go cylinder or operation is minus. So and you can go for -2 or 3 or 4, depending on the diameter. You can select your operation and select your expression. Okay, that is for the lower expression, and the upper expression you have to select for both. So mostly, if I were there, I'll select -0.5, and the upper selection I'll put a much bigger value, maybe 5. So it'll go for the direct diameter of the cylinder. Okay, so you can select that. So this is how you can select your diameters. Let's check one more example. Suppose I try to create toolpaths. I'll just delete these. And we'll quickly go on to select some of these holes here, much simpler ones. But they are of different lengths, depending on the diameter, different lengths. So let us select, okay, very similar. Okay, that's the one. So we can suppress the rest of them. This is one more, this is one more. We'll suppress that, and then we get to here. Okay. So okay, these are simple holes. I'll show you the same expressions that I applied for these holes. So for each hole, you'll find a central drill. There is a drill that is coming for the diameter. Then there is a countersink that is creating this chamfer. Okay, so that is like a countersink tool will be coming and acting like a drilling toolpath. Okay, it is not a circular motion, so it is like a drill. Okay, now again central drill. Then there is a different diameter of tool, and then there is a countersink. So similarly, you can generate your programs. So for each diameter, it is taking a different tool. And I'll show you that technology database where the values are and how it is set. So if I go in here, it will take me directly to the technology database. And we'll find the expression for diameter, or for the tool that is to be selected. So you can set them similarly. Okay, so these are the guys. So these are the center drill. For the center drill, I think it is also set as expression. For the drill, it is also set as expression. And you can see the diameter operator is plus, and I've set 0, 0. So for the countersink, this is also an expression, sink diameter, and so this has a bigger value because you need a bigger tool just to get you that chamfer. So that is why it is in plus. Okay, so we can set all these expressions like this. Okay, if I go and create the toolpaths and then try to simulate, then we can slow it down. You can see the simulation. It is exactly selecting the cutter and creating the chamfers as well. For all the holes. Yeah, so this is how you can select your holes for different size. So you need not go for toolpaths for each hole separately. Okay, so you can define just one strategy and it will apply for all similar types of holes. Okay, so you need not go and save the operation plan for each and every hole to create those features. If the hole is much different, the diameter is different, you want to treat it separately, treat it as a different type of hole, then you can set up a different strategy, because if you want more number of tools to be involved in removing the metric. Okay, for similar strategies, you feel that it is valid for all these holes, you can go for just one strategy. That should work. Okay, let us now get into another file, which is very interesting now. We can open this TVM. So many of you have already used this TVM. You know how it works. For those who don't know, I'll just give them some brief. Okay. Now, if you go into the technology database, we'll set up those parameters inside. I'll show you how. Okay. And today we'll do something interesting, so that you understand. Now here, if you go into the CAMWORKS TVM, you will have tolerance-based machining. So the first icon here is to run the strategies. What are the strategies? Recognize the tolerance range, machine to mean. If you have side allowances, it will take those reviews, recognize the ISO standard limits and fits. So this is one there, and then you have got recognize the multiple multi-surface features. Okay, so recognize the multi-surface features as well. Apply color to multi-surface features. Recognize the GDNT. So all these different options will be available. Okay, so there we'll have the state mass, circular runouts, total runouts, and all those stuff. This will also override the ISO 286. So these are all the strategies that are set already. Okay, so if you don't need to run, so these are multi-surface features, nothing is inside there, no colors, nothing. So we'll set it up, and then you have the tolerance range. So if you for any hole, if you have tolerance range between 0 to 0.5, then you have a board, so you can choose any strategy from here. Okay, I'll tell you how to choose the strategies as well, and then you can select your operations from here. So I'll change that to drill, should not be them, because it is an open tolerance. Okay, now here you can create the features and then run it within CAMWORKS. All right. So let us now setting up the strategies. It is not here. So we go up and go into the settings. Okay. So this is where you actually set the parameters, and only the features can be generated from the first icon. Now here you have the settings for each and every. So there you set it as drill. Okay, so by default it will be drill when you go in there. Okay, so all the settings should be done here. Okay, so similarly, same tabs will be available, and we'll go into the multi-surface feature. Okay, we are not interested in the holes now, so we'll set up a multi-surface feature. So here you can see some multi-surface features. So 1, 2, 3, 4, and there is a tag here: 32, 63, 125, 250. Okay, so we'll set up tolerance range between which these surfaces would lie, and what toolpaths will apply here. Okay, so how to set up the finishing range. This is something interesting. Now you have to add the finishing range, the strategy, and the color. Okay, so we'll set it up. So first, if you click here, it will give you the range. Okay, now the finishing range, first we'll start with 0, let's say, or maybe not with 0, maybe 10. Okay, so I'll add it, so it will add a finishing range of 10, then I'll add 50. Okay, so if I say 10 to 50, this surface should lie within that range. So because this is 32, okay, then I will add 80. Okay, maybe this is 63, so this comes within that range, or maybe 100. Okay, so let's add 80, and then we'll have one more range from 100 to 150 maybe. Okay, so we'll add 100, then add 150, and then we'll add, this is 250, so we'll add a 250 as well. Okay, so our tolerance range would range between 0 to 50, 50 to 80, 100 to 150, and then 150 to 250. Okay, something like that. Okay, so if I do here, these will appear. Okay, I think we have one extra, so we can get this to, okay, this is good. 10 to 50, this is good. 50 to 80, this is good. 80 to 100 is not required, so we can delete that. Okay, we'll see what strategies. I have some fixed strategies here: 10 to 50, 50 to 80, 80 to 150. Okay, so directly 100 is removed. We don't need 100. We can just delete the 100. Now it is all right. So 80 to directly 150, this surface will fall under that, and then 150 to 250, this surface will fall under that. We can select the strategies, go into the strategies. I'll show you what strategies I have. So we'll set this up. So I have a strategy for each of these tolerance range. So we'll go into the technology database. I will take you to multi-surface features, and I'll show you what strategies they are. So I just created a finishing strategy pattern. So here there is a pattern project with some parameters and just a single toolbar to give you what kind of finish you need. Okay, so the step over for each of these toolbars will be different. Okay, depending on the tolerance range, so you know exactly what is happening. Okay, so if the tolerance range is within 30, there will be a different step over. If the tolerance range is from 100 to 125, there will be a different step over. So where does it get the value? It gets the value from these finishing strategies. Okay, now how do we apply it to the tolerance range? Is here. Okay, we'll go into multi-surface features. We'll say tolerances. We'll set up the tolerance range. Then we'll set up the strategies, and then we'll set the color. Okay, so let's get the color going. So we can have this one. Then we can have another one. Okay, we can actually give any color. So this one there, and go for a little lighter one. Okay. Okay, these are the colors. Okay. Then we'll go to the tolerance range, and we can select those apply color. Okay, so we need to run it as well. So here you will see all the strategies set. Okay, so basically go and run it from here. So extract the machinable features. It will extract the multiple surfaces features, and it will apply depending on the surface finish tag. It will identify the surface, generate a multi-surface feature, apply the colors, apply the strategies. So this is what the tolerance-based machining does. Okay. Now it is creating all sorts of other things as well, so it is taking time. So now you can see the multiple surfaces has been identified, it has been colored, and you have those strategies in place as well. So these strategies are also assigned. Okay, so if I just go in there, generate the operation plan, you'll get the respective toolpaths. We'll try to run the first toolpath. We'll see how different strategies will have different stepovers with the same cutter for similar surfaces. So now this is having a different stepover just to maintain the finish. Then we'll have one more. Then we'll have a different step over here. Then from range 80 to 125, much more wider step overs. And then for the 250 range, even more wider step overs. So depending on the surface finish range, you can define different strategies, and you'll get different step overs on different surfaces. So this is what your TVM can offer you to do things automated. Okay. Now you'll have a fair idea of how to set up the database and how it will be linked to the tolerance-based machining. Okay. Next, quickly go on to another file, which is even interesting. Okay, and you can set up your strategies now for dies. Okay, now how you can do that? So I have okay. So we'll multi-surface feature, and there I can set it up as a connecting rod. So I have a set of strategies made for this connecting rod. So this is applied to a different die. Okay, I had made one strategies for the connecting rod, and this is applied to a set of die. Okay, so we can even set this up and run on a connecting rod as well. So this is the bottom right for the connecting rod, and we can find the top die, we can apply that as well. So now look at the toolpaths. Okay, I have area clearance, which is going 16 hog nose, then a 6 ball nose for rest machining, then a 4 ball nose again for rest machining, and then we'll go with the 4 ball nose as a finishing program, and then a 3 ball nose for the corner finishing, a 2 ball nose for the corner finishing, and then a 6 ball nose for these outside areas, that is called the gutter areas, And then we've got a flat finishing for the rest of the part. Okay, now let's get started. So generate the toolpath first. So we'll see how the toolpath goes for each one of these strategies and how they can look. So you can set up all these parameters inside the database, and similar parts can be used. So anything, any similar type of components you're doing can be applied. So now you have got the area clearance. Then we'll go for the next 6 ball nose and use it as a rest roughing. So it'll find material where the 16 bull nose could not cut. So it will mostly cut inside those connecting rod areas where the larger cutter could not get in. And then we'll use 4 ball nose again for rest roughing those areas. So within 1 or 2 minutes, you can actually program such parts if you have your database ready. Okay, so you get these 2 parts for the rest roughing. Then we'll have 1 more rest roughing. Again, it'll find material where the 6 ball nose could not go. So it'll go and find areas where the 6 ball nose could not enter, and there is material to cut. It will cut all those areas. Well, you can set up the strategies, but you cannot set the strategies or set the content area or the avoid areas. Okay, so for each and every part, the content and the avoid area will be different. So you have to set up the content and avoid area depending on the part. Okay, so now you have the toolpath for the 4 ball nose as well. And then we'll go into the finishing. So for the finishing, you have to set up, I'll show you content area. Okay, so you can select this, very quick to select all the content areas. You will have to use this multiple button to use both, and then just say okay. Now I want to create a toolpath within that. So I'll just generate the toolpaths. And then I have the corner finishing toolpaths. By the time this is calculating, I can go for the corner finishing toolpaths as well. So let's calculate the corner finishing toolpaths. And we can run the flat areas anytime after the finishing program is done. So we can run it before the corner finishing as well. So the corner finishing is getting calculated. We'll go for the second corner finishing with the 2 ball nose, and then we can go for the finishing outside the boundaries that we have just set. So the main cavity area is important. The finish has to be maintained there, but the outside area, there will be material flowing outside, is the flush area. So not much finish is required. We can save some time and generate it separately. So all these toolpaths are getting calculated. So you can see the toolpath here inside the cavity. Okay, smooth and fine. And then we'll have the toolpaths for the corner finishing. The first corner finishing is over. We will have toolpaths for these corners. And then we'll have another toolpath with diameter 2 for the corners. By the time it is getting calculated, we can set up content area for so this is the content area, but we also need an avoid area. So inside the toolpath you can have n number of content and avoid areas. I need an avoid area. So we need to contain the toolpath within this boundary, but we also need to avoid it from going into these areas because already they are finished. Okay, So now let's calculate that. And then we'll last go into the flat areas. For the flat areas, I don't want them to go into the cavity areas, except that it can go into the rest of the areas. So just add avoid areas and say don't get into these areas. And now we can calculate the so we'll go and check the finishing program, corner finishing for 2, and then we can get into the other programs, the one for the flush areas and the final flat area finishing. So similarly, you can apply these to different die sets or similar die sets with that you have, so you can make programs for different die sets, and you can literally program your parts in minutes. So let's go into the simulation, check the simulation. So go to the rapid because we are close to finishing now. You can apply the quality and then go for. So let's finish. So the first roughing program, and then the rest roughing with 6 ball nose, and then the rest roughing with 4 ball nose, and then the finishing 2 numbers. And then we'll have a corner finishing with 3 ball nose, and then corner finishing with 2 ball nose. So the cavity area is finished. The corner finishing is done. We can check the cavity area. Look at the cavity area. And then we'll have the outside flush area, and then we can do the final flat area finishing. So you can decide your strategies, save the operation plan, and then apply it to any material or any type of parts. So you can decide on the range, on the box size of your part, and then apply the strategies. Finally, you can do the checking that all the material is removed, and you can use the strategies for different parts. So before we end, I just want to show you the technology database where this is all happening. So we go into the technology database. I want to show you multi-surface features and strategies here. So you go into the connecting rod, and there are all the strategies you have. Okay, all the tools set for these types of parts. Stock material is set to all. So if you want to change that, you can change all these types and switch it up, and these are the okay. All right. So similarly, you can set up your technology database for turning, turn mill parts, milling. So all different types of machines and tools. Okay. Hope you have a good idea about the technology database, how to set it up, set up the strategies for your parts and features. Hope you work more with the technology database and get used to it. So because this is the most important thing in CAMWORKS and will stand CAMWORKS out with a difference to other competitors. Okay? Right. Thank you so much for attending today. Next time we'll join with a different topic. I'll let you all know. Thank you all for your patience and have a good day. Thanks. Bye-bye.